This lesson is over prime factorization. So let's review our previous lesson over powers and exponents. We have 2 cubed, or 2 to the power of 3, and we have 3 squared, or 3 to the power of 2. Is 2 cubed equivalent to 3 squared? According to this, there's a big O not equal. Well, let's see. They both have the same numbers, so why wouldn't they? The base is 2. The exponent is 3. That means it repeats itself. This factor repeats itself 3 times. The base is 3. The exponent is 2. That means this base or factor will repeat itself twice. So 2 times 2 times 2 is 8. 3 times 3 is 9. Oh, so they are not equivalent. So Yellowstone National Park is known for its 10 to the 4th power of hot springs and geyser, which is more than anywhere else in the world. Write 10 to the 4th power as a product of the same factor. How many hot springs and geysers are in Yellowstone National Park? Well, the base is 10. The exponent is 4. That means this base of 10 will repeat itself 4 times. So 1 times 1 times 1 times 1 is 1. There are 4 zeros that follow it. So the answer is 10,000 hot springs and geysers. Alright, let's watch a movie whenever it loads up. And let me get an arrow.
Wait a minute. Those are numbers. That was a 3. The one before it was a 2. Base 10 numbers. Just start counting now. See how far we can get. 1. 7.
Ooh. So that's from the movie called Contact. Her name is Dr. Elsa Arroway. She recorded these numbers. On the computer, you saw 2, 3, 5, and 7. Can you continue the pattern up to the 10th term? What are these numbers called? Let's see. 2, 3, 5, 7. So we're adding 1, adding 2, adding 2. No, I don't think the pattern is that one. 2, 3, 5, 7. Oh, I think the next number is 11. Then 13, 17, 19, 23, 29, 1, 2, 3, 4, 5. And those are the 10 terms. Do you know how I came up with those numbers? And what are these numbers called? They are called prime numbers. And those are prime numbers. Again, what are prime numbers? Prime numbers is a number that can only be multiplied one and itself. They only consist of 2 factors. For example, 2 is only consists of 1 times 2. 3 is 1 times 3. 5 is 1 times 5. 7 is 1 times 7. 11 is 1 times 11. Why couldn't it be 15? Because you have 15 consists of 4 factors. It's 1 times 15 and 3 times 5. So let's practice this. Classify these numbers as prime or composite. 5, 1 times 5, prime. 8, 4 times 2, 1 8. That's composite. 21 has 3 times 7, all kinds of numbers. 24 has a lot of factors. 27 is 1 times 27, 9 times 3. 9, 3 times 3, 1 times 9. No, it's composite. 2, 1 times 2. 6, 3 times 2, 1 times 6, composite. 12 is composite. 13 is prime. 51. 51 is 1 times 51. Did you know it's also 3 times 17? That is composite. What about the number 1? 1 is composed of the factors are 1 times 1 or 1. It only has one factor, so it's neither. So the first 5 prime numbers are 2, 3, 5, 7, and 11. We are going to be working a lot with 2, 3, 5, and 7, but especially 2, 3s, and 5s. So what is prime factorization? It is finding which prime numbers multiply together to make an original number. To find a prime factorization is helpful to make a factor tree, and this is a factor tree. So to make a factor, and then prime factor is a factor that is a prime number. So, for example, we have 60. The factors of 60 are either 6 times 10 or 2 times 30. Can you have more factors from 6? Yes, 2 and 3. We circle those because those are prime factors. 10 is composed of 2 and 5. We circle those 2 and 5 because they are prime factors. 60, that's 2 times 30. We circle 2 because it's a prime factor, but 30 can be broken down in 2 and 15. Circle to 2. Can 15 be broken down into more factors? Yes, 3 and 5. So as you can see, even though we did it different strategies and different methods, they both consist of a 2, another 2, a 3, and a 5. So we could say it's 2 times 2 times 3 times 5, which equals 60. Or we could write it using exponents, 2 squared times 3 times 5. So we are going to practice this. Our first number is 135. What are the factors of 135? Well, 5 would be one of them. 5 times what? I have no idea, I'll be honest. So let's divide this by 5. It goes in 2 times, which is 10. That's 35. That goes in 7. Oh, so it's 5 and 27. I circle 5 because I cannot find any other factors for 5 other than 1 times 5. So it's 5. And it's prime. 27 is 3 times 9. Is 3 prime? Yes. I circle it. I cannot break it down anymore. But 9 is not prime. It's a composite. It can be broken down into 3 times 3. These are prime numbers. So what makes up 135? 3 times 3 times 3 times 5. Can I write it using exponents? Because I like repeated multiplication could be written shorthand using exponents. 3 is the base, 3 cubed times 5. Negative 120. Well, this can be broken as negative 1 and times 120. Prime, because it's negative 1 times 1. Negative 1, that's 2 factors, so it's prime. How can I break 120? 2 times 60. I could have done 30 times 4, and anyway. So 2 is a prime. 60. 2 times 30. I could have done 6 times 10, 3 times 20, but I chose to do 2 times 30. 2 is prime. What makes 15? I don't know. 2 times 15. That's a lot of 2's. 2 is prime. How can I break down 15? 3 times 5. 3 and 5. So it consists of negative 1 times 2 times 2 times 2 times 3 times 5. But let's write it using exponents. Negative 1 times 2. It repeats 3 times, so 2 cubed times 3 times 5. With 254 counties, Texas has the most of any state in the United States. Generate an equivalent expression using prime factorization. So we have 254. It is composed of 2 times something. So 254 times 2. It goes in 1 time, 12 times, which is 24. and this goes 7. So 127. And I honestly do not know. I believe I could be wrong. So I'm not going to redo this video, but I think I know 2 is prime. I think 127 is also prime. I can't figure out how I could break that down anymore. So I guess it's 2 times 127. The paint company has 500 different colors. Generate an equivalent expression using prime factorization. So it's 5 times 100. 5 is prime. I circle it. 100. 2 times 50. 2 is prime. I circle it. 50, I don't know. I could do 2 times 25. I'm going to do 5 times 10. 5 is prime. I circle it. 10 is 5 times 2. 5 is a prime number. I circle it. 2 is a prime number. So how many 2's do you see? It's composed of 2 times 2 times 5 times 5 times 5. Or 2 squared times 5 cubed. So in this one, negative 144. They say the prime factor is negative 1 times 2 to the power something times 3 to the power something. So negative 144 is negative 1 times 144. I circle negative 1. It's prime. 144 consists of 12 and 12. 12 is composed of 2 and 6. Circle it, prime. 6 is 2 and 3. Prime, prime. 12. Can I just repeat what I just did previously? Yes, I can. Prime, prime, and prime. So I have negative 1. How many 2's do you see? 3 of them. How many 3's do you see? Wait, no, stop. How many 2's do I see? 1, 2, 3, 4. So A should be 4. How many 3's do I see? 2 of them. So what is the sum of the 2 exponent? It would be 6. Sometimes you are given the prime factorization. Can you go back and tell me the original number? So 5 squared, that's 5 repeated twice, times 3 squared, that's 3, the base of 3 is repeated itself twice. So 5 times 5 is 25, 3 times 3 is 9, and 25 times 9 is 225 is the original number. And if you checked your work, if you broke down 225, it would consist of 5, 5, 3, and 3. So in here, 2 cubed times 7 squared, that's 2 times 2 times 2 times 7 times 7. And what is 2 times 2 times 2? That's 8. What is 7 times 7? That is 49. So 8 times 49 is 72, carried as 7. 8 times 4 is 32. 33 to 4 divided 6, 7 to 8, 39. I believe it is 392. So this is the study of prime factorization, where you're given an original number and you can break them down into prime numbers, or you're given the prime numbers and you can multiply it back together to find the original number.